Hey guys, we're going to talk about solving multi-step equations. So what we're going to do is we're going to solve these and check our work. But before we get to that, let's talk about what it takes to solve an equation. The goal is to get x alone. So we want to get x all by itself. Once we've accomplished that, then we know we have solved the equation. Now the hard part that students struggle with is they don't really know what to move and when. So what I use as a guideline to figure out, hey, what piece should be moved and when, is you're going to actually use the order of operations. So PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Except how are you going to use that since we're unpacking and want to get x alone? So we're trying to get everything away from x instead of compressing everything and condensing it. We're going to do the order of operations backwards, which means we're going to get rid of any addition subtraction first, then we're going to get rid of multiplication division, deal with any exponents we have, and then finally work inside parentheses. So got three examples for you, and again we're going to work the order of operations backwards. So I have 49 equals 9 minus 4x. So what I do is I look at what side has the x, because remember we're trying to get x alone, that's where the focus is. So I have this 9 minus, so we have a subtraction 4x. When you see that 4 and that x together there, that means multiplication, 4 times x. So we have subtraction and multiplication. So working the order of operations backwards means we have to get rid of addition, subtraction first. So that would mean we have to deal with this 9. So the opposite of having a positive 9 is we're going to subtract 9 from both sides. So I'm basically taking this 9, using an inverse operation. Instead of addition, we're going to do subtraction to move it to the opposite side. 49 minus 9 is 40. On the right side, I have 9 minus 9, which is 0, so that's going to go away for us. And we still have this minus 4x here, so there's my minus 4x. So I've moved the 9. Now I still have to get that x alone, and we talked about the subtraction here and multiplication. Well, now I'm dealing with multiplication where it's negative 4 times x. So the opposite of multiplying by negative 4 is dividing by negative 4 on both sides. So the reason that works is when you multiply and divide by negative 4, this actually, negative 4 divided by negative 4, that's like 1, but we don't really write 1x, we just write x. What's going to happen here is the multiplication division is going to divide out, so we just get an x on the right side. On the left side, we have 40 divided by negative 4, which is negative 10. Now, all I have to do is, it does ask us to check our work. So I'm going to show you what that looks like. So we're going to just take this x equals negative 10. So I'm going to rewrite my equation up here and plug negative 10 into the top equation. So we have 49 equals 9 minus 4 times, instead of x, we're going to multiply it by negative 10. And what I'm checking to see when we're checking our work is I want to see, does the left side of the equation equal the right side? So on the left side, I have a 49. On the right side, I still have a 9. I have negative 4 times negative 10, which is 40. Still have a 49 on the left side. Now I can do 9 plus 40 on the right side, which is 49. So I get 49 equals 49, which means my x equals 10 works. I have two more examples for you, so you can see a little different style questions. So this next one I have x divided by 3 minus 7 equals 5. Again, the focus is on the side that has x. So I have division by 3 and I have subtraction by 7. So thinking about the order of operations backwards, I got to get rid of the addition subtraction first. So I got to get rid of that subtraction by 7 first. Then I deal with the division by 3. So the opposite of subtracting 7 is adding 7 to both sides. So when you have a minus 7 plus 7, that's 0. So we're got that gone, so I have x divided by 3 still on the left side. On the right side, I have 5 plus 7, which is 12. Continuing on from there, got rid of my subtraction. Still have a division by 3. The opposite of dividing by 3 is multiplying both sides by 3. Again, we have multiplication, division, so those are gone. I have just an x. On the right side, we have 12 times 3, which is 36. So we have x equals 36. As always, we would like to check our work. So I'm going to take this 36, plug it in for x, see if the left side equals the right side. So 36 divided by 3 minus 7 equals 5. 36 divided by 3 is 12. Didn't touch the minus 7, didn't touch the 5. 12 minus 7 is 5. 5 does in fact equal 5. One final example. I have x minus 3 divided by 4 equals negative 3. Again, the focus is on where is x. So x is on the left side, which means I got to get rid of this minus 3 and this division by 4. Now, we are still doing the order of operations backwards. PEMDAS backwards. So if you're thinking about that, you might look at this and think, all right, well, I got to get rid of that subtraction by 3. We actually cannot touch that x minus 3 quite yet. The reason being is we have a giant fraction here. And the fraction really acts as a grouping symbol for the numerator at the top. So really that x minus 3 actually has parentheses around it. So we cannot touch that minus 3 up there until we get rid of everything else with it. So there's really parentheses there. They're just not written in. That's not how we do it notation-wise. So if I can't take care of that minus 3, I can deal with that division by 4 first, because no addition subtraction can deal with the division. The opposite of dividing by 4 is multiplying by 4. So since we're multiplying and dividing by 4 over here, we're stuck with just an x minus 3 over there. So those are inverse operations. Negative 3 times 4 is negative 12. Only thing left to do is solve it. So we have the minus 3 now. The parentheses are gone since the fraction's gone. Add 3, and we get x equals negative 9. As always, we need to check our work, make sure we're doing things correctly. The left side of this equal sign should equal the right side of the equal sign. So we have negative 9 minus 3 divided by 4 equals negative 3. Negative 9 minus 3 is negative 12. Didn't touch the division by 4, didn't touch the right side. Negative 12 divided by 4 is negative 3, and negative 3 does in fact equal negative 3. That was a video showing you how to solve multi-step equations. Just make sure we're getting x alone and work PEMDAS backwards.